Okay, the computer says the recording is going and we're gonna start going then. Let's look first at our class schedule here and see what's coming up when. So I'm gonna engage my student view. There we go. And let's go over to our calendar and see what is coming up on this thing that we need to do. Oh, we have a whole bunch of stuff due tomorrow. So let's see what that is. The first one is a discussion, and it's on the future of the automotive industry in California. Last fall, Governor Newsom made a pledge basically to make that shift from gasoline-powered cars to electric vehicles by 2035. I want your guys' input and opinions on this stuff. It's one of these things where no matter whether you like it or you don't like it, you know, you're going to have to deal with it in some shape, form, or another. You guys know me. I'm a racer and I'm an engine builder, right? So I like pistons and valves and rotors and all kinds of things. But I've had the opportunity to drive several different electric cars now, and I'll tell you that, you know, they're pretty cool, and definitely for like commuting back and forth to work, and it's nice, you know, and you know, if you got a charging station at home and you can plug the car in and charge it up, it's actually convenient. You didn't have to go to the gas station. I think you know, that actually not only saved money in buying gas, but then you weren't at the gas station maybe buying snacks or anything either. So anyways, so that discussion is due, and I can't wait to read all your guys' comments. I have read a few of those, and I'm looking forward to getting through the rest of them. So we have a lab quiz sheet. Let's check this out. What is this? I want you to answer some questions about the multimeter that you have for this class. So it could be, maybe you have this cheapy Harbor Freight one here, or maybe you went to ARC and you picked up the Performance Tools one, or you bought one. But basically, this thing asks you a few questions specifically about your meter, and you answer those. In fact, I'm going to click this thing right now and do it under my login. Now it's inputted as a quiz, but the way Canvas works is some things that really aren't quizzes, it lists them as a quiz just because that's kind of the limitations of the system. So this is like a short answer quiz. So what are the features of your multimeter? Let's say we have this yellow one on the screen. Now that's exactly like this Harbor Freight one, pretty much. And actually I have a copy of it right here that's black. That's exactly it. I bought this one off of Amazon. So what can both of these things measure? Well, this one can measure volts, amps, ohms. But it can do a few other things. It can do a diode test. In fact, I'm going to put my meter right on that arrow. And what you'll see on the screen there, in the little corner of your screen likely, is the thing pointing towards a symbol. And that symbol looks like, if I can get my annotation tools up, that symbol looks like this. It's got a line going, and then it's got an arrow with a line like that. And that's the symbol for a diode. So this thing does some diode testing. He does, he's got the ability to test transistors right here. So even this inexpensive meter has some pretty cool features that it can do. So the idea is that you'll have to read the little manual or instruction sheet or look it up online so you fully know all the stuff that your meter can do. Okay. It asks you about the CAT rating of the meter, right? What category? Think of that as like a safety rating of the meter, right? What's the resistance of the leads? Max amount of amps this meter can measure directly. Well, I'll tell you, like this Harbor Freight one I have right here, I guess an effort to make it inexpensive, this guy can only measure 5 amps of current on him. And let's see how much resistance he has in his leads. It kind of depends on how I test them. Like sometimes you got to rub them back and forth. And right now I'm getting not super happy with it, really. I'm getting a little over 2 ohms of resistance in its leads. So anyways, so you'd fill out all these answers to these questions. And when you're all done, you'd say submit. So it's not like a traditional quiz where you're selecting A, B, C, or D. It's a short answer that gets you thinking about your meter and what can it do, okay? So that's that lab quiz sheet 1 using your meter, okay? Why is it a lab quiz? Because you're actually, you know, doing something a little bit hands-on, right? So I'm going to go back to the calendar and let's look at that other assignment. Lab quiz sheet 2, basic meter knowledge. All right, so this is going to ask us a few things about the meter. It is like a conventional quiz. So answer the questions. What does it mean when a meter has high impedance? Now, impedance is a kind of a fancy word. What it means is when you take inductance and resistance and put them together, you have impedance. You're likely to see the word impedance if you've ever looked at stereo speakers. In fact, let's look at some stereo speakers. Let's see. There we go. Here's some nice Alpine speakers from Crutchfield. Let's say we're going to throw those bad boys in their car. 6.5 inch. Okay. Looking pretty good. Details. All right. We got a 1-inch dome tweeter and sensitivity. I'm surprised they don't tell us. What the impedance is. Let's try another one. Actually, let's look at this. My goodness.
You missed it.
I missed it? Was it right there?
Right there.
Oh gosh, the light shading of the gray, just that little bit. Thank you so much. The light shading of the gray threw me off. So see how it says impedance, 4 ohms? And when you're doing speakers, by the way, like you could hook the stuff up at, like, if let's say you're doing like a subwoofer enclosure or something, you could decide to hook stuff up in parallel or in series, depending upon what you want to do with this. But impedance is really, think of it, if you want to think of it really simply, it's resistance, but inside a speaker, there is a coil of wire. It's like a big electromagnet here. And you can see that magnet. What you can't see is the coil in there. Well, remember that whenever we flow electricity, right, when those electrons are moving through wires, they create, so here's my electrons moving through, they create a magnetic field around those wires. And of course, if I want that magnetic field to be stronger, instead of just having a straight piece of wire, I'll coil it up, coil it up, coil it up. Well, what happens, and we haven't got really into this, but as the current's trying to flow through here, this coil of wire generates a magnetic field. That magnetic field actually then generates voltage to oppose the flow, and it's called counter electromotive force, or CEMF. Anyways, it's a special thing that once you take a wire, you start coiling it up, let's say this way, you know, funky stuff happens. And so impedance is not just taking into account the resistance, it's also taking in account the inductance, which is related to what's happening here as we're flowing the current through the coil of wire and what its resistance is. So anyways, for our intents and purposes as automotive technicians with our meter, just think of that impedance factor this is what the meter's internal resistance is, okay? And for the most, for most intents and purposes, even if you were looking at this speaker here, and I'll clear out these drawings, you could look at it and say, okay, well, this speaker has an internal resistance of 4 ohms. And look at it that way, and then make sure that the amplifier you're going to connect it to, or car stereo, can handle a 4 ohm load, right? I think what's interesting, right? You might have, you might look at a speaker and maybe it's, maybe it's 4 ohms, maybe it's 2 ohms. And then, you look at the specs for your stereo and it says, okay, well, it can't handle anything lower than an 8 ohm load. And you think, well, why would that be? Well, remember Ohm's law, right? If we do volts, amps, and ohms, hey, if the resistance goes down, that means the current flow is going to go up, and maybe that's going to be too much current flow coming out of our car stereo. Here's what this box is supposed to be, and that could burn up that car stereo. So anyways, Ohm's law always is in effect there, right? It's always playing a role there, and so it's kind of interesting as you get into this stuff. You start peeling back the layers to see how everything is related. So, thank you for helping me find that that specification there on that speaker. All right. So most of these are pretty straightforward, like what jacks do you use to measure voltage and ohms readings, and what position do you use the dial in. On all these little pictures here, the example meter that we're going to use is this snap-on meter. So if I hold this up to the camera, you'll see that it exactly matches the bottom of that sucker, okay? So a lot of it is making sure that you know how to use the meter and where to put the leads, that type of thing, okay? So that's the third thing that's due. So if I go back to the calendar, okay, so there's 3 things due tomorrow. And you know that because it's on the calendar, and now we've kind of reviewed that. And none of these things really are that difficult. By this point, you should have a multimeter in your hands, so the second one should be easy to do. You can notice that, like, I did this one, so it drew a line through it because I've submitted that assignment. Where are we going with stuff? Where we're going next is some charging and starting system diagnostics. And so this is what we're getting into tonight, okay? In fact, let's click this one and see what it's going to ask us to do. Move that guy out of the way. All right. Don't forget that you're doing some of these assignments. Sometimes it will ask you to submit a picture or something. If you get the Canvas app for your cell phone, it does make doing that process a little bit easier. So that's one way to go about getting those pictures and stuff submitted. So for this activity, you're going to perform some basic testing of charging and starting systems, DC voltage. So to do this activity, you really do need access to a car. Now, I have some kind of backup, like contingency plans where you could do some stuff with videos and stuff, but I would really prefer if you did this thing hands-on on a car. So what do I have here? I have, hey, make sure you've done the waiver, you've taken the SP2 safety test. It's always a smart idea to wear your safety glasses. I'm not going to ask you to get your car up on jack stands and get underneath it. Hopefully you have a car that's relatively easy to access the battery. There's been a few cars I went to work on that, getting to the battery is a real bear. And if that's the case, just, show me what car you're working on and we'll figure out something, right? But the idea is if you have a car that's relatively easy to get to that battery, throw it on DC volts, test the voltage of the battery on your car, and then you're going to see like what's the state of charge, what's the available voltage, and you're then going to record a little video of you doing that, because in the video you'll see some numbers kind of bounce around. It's not like the meter's going to be static. You're going to see the numbers moving around on you. And then you're going to let the engine start up and look at your voltage output. And, you know, again, take a little video of that. When you get those videos done, what you do is you click submit, and then you can select the file and load them up in there. So you're doing a couple video clips, and you know, this is actually a really common test, and it's super easy because all I had to do was hook my meter to the battery and then look at what it was. I might have had to turn on my headlights for 30 seconds, suck off a surface charge, and then I start my car and I see what happens. Okay, so in fact, we're going to go into the diagnostics behind the scenes, what's going on, but it's super easy, quick to do, and it actually can tell you a lot of information. Okay, so that'll be what's due next Friday. So to give us the backstory on this thing, we're going to change our screen share, and we are going to go into my battery diagnostics presentation here. Let me get that screen share set up. Boom. Okay. So battery diagnostics. What do we got here? Remember, the job of the battery is not only does it start the engine, it's going to supply all the electricity for the vehicle until it starts running and the charging system, that alternator or generator, takes over. Okay. So it's got an important job. And then, you know, thinking big picture on stuff, we've talked about AC versus DC, right? Alternating current versus direct current. Why are our cars direct current devices? Because they use a battery. Batteries produce direct current voltage. I don't care if it's a AA, or it's a 12-volt battery in your car, or it's a 300-volt battery pack out of a Tesla or something. The batteries are DC devices, okay? Okay, so a couple safety things: never lay tools on your battery. You don't want to lay this wrench on there and cause a short between the battery posts. Batteries do produce a hydrogen gas that is easily ignited. So whenever we're working on batteries, we want to kind of go out of our way to not make sparks near the batteries. We want to take off any rings, metal wristwatches, stuff like that. We always want to be heads up whenever we're working near a battery. Okay. If you're going to disconnect things, it's always smart to disconnect the negative first, right? And then connect it last. So I like to say this: the negative cable hangs out on the battery the least amount of time. Okay. Follow manufacturer's recommendations when charging. Why do I say that? Well, some vehicles have a conventional lead acid wet cell battery that you can fast charge and stuff. And some now have what we call absorbed gas mat batteries. And those batteries do not like to be fast charged. And they have new battery chargers now that actually have an AGM-like selector or function. But if you don't have one of those, then you have to hit those on a slow charge. And so, you know, when in doubt, always follow the manufacturer's recommended recommendations. Now I have this one here. It says only add distilled water to a battery, and that is true. But I will also say that with most batteries being sold today, if you take the vent caps off and start messing around in there, that in itself will void the warranty of the battery. So I'm now advising people, don't take those caps off. You know, just do your external tests. And I said this one before: no jewelry, no arcing, right? So we got all of our precautions in there. you know, one thing that's not on here, but we'll get to here in a second, and maybe we've talked about it before, is if we disconnect the battery, right, it's going to likely clear out the radio stations. Cars in the 1990s were really popular to have, and even some in the 80s, where they had like a special lock in the radio. So if you disconnected the battery and you went to get the car going again, now the radio didn't work because you had to put in a special code. And 9 times out of 10, the customer had no idea what the hell the code was. I can't tell you how many cars I had to take the dash apart, pull the stupid radio out of the dash, read numbers off the back of the radio, and call up the dealer and say, okay, I'm at, you know, blah, blah, blah shop. And, you know, can you please give me the radio reset code? So pay attention to stuff like that. Also pay attention that, hey, if I disconnect the battery, okay, this battery is what supplies the memory to the computer, right? So if I'm going to draw another line here and go over here, and there's going to be some box on the car, right? That's going to be the PCM, powertrain, control module. There's likely to be a body control module and several computers on the car. And so if I disconnect the battery, that will likely reset all the information in this computer. And he will be like, what's going on? Now, most cars, it's not too big of a deal. You hook it back together, the car starts and drives. But if we are getting a smog test done, well, that's going to clear all of our emission monitors. And now it's not going to know what's going on, and it's going to fail smog until the car gets driven quite a bit to run all those emission monitors. And this is one of the things we've been talking about off and on in the AT188 class, as we're looking at scanners and OBD2 diagnostics. A 1996 or newer vehicle is kind of actively testing its emission control devices, and you blow out all those test results when you clear the codes in the car, or if you disconnect the battery, that can clear all the codes out of there. So there are some cars, and I've heard several horror stories. I've had this happen on some BMW products where you disconnected the battery too long, various modules lost power, and then you had to do a initialization on those, and we didn't have a scanner that was able to do that. So we ended up just trying to, we were doing a mechanical service job, disconnected the battery, and now the car, before we were done with it, we had to, you know, have it towed over to the dealer so that they could hook up the factory scan tool to get it going. So, you know, there's always some precautions. So these days, I would say, if you're going to disconnect your battery, well, do some research, right? Find out if it's going to be a major nightmare on your car or not. If you suspect it is, then you want to have some type of memory saver. So this is the little cheapy memory saver, and I don't really like these ones. They only work about half the time because that battery at best has 9 volts, right? Well, 9 volts may not be enough to keep the computer's memory alive. This one that's pictured right here, this one gets my big green thumbs up, man, because these ones work pretty good. So you hook it to like a jump box that's off the vehicle, that plugs into your OBD2 port, and pin 16, and this is something else we've been talking about in the scanner class, pin 16 provides power to your scan tool, but what it also does is it will go back to the power distribution box, and typically that will feed back to your computer, and it will keep your memory circuits alive. Okay, so those work pretty good. Pins 4 and 5 of the OBD2 connector are ground, and it doesn't matter if it's a Chrysler, Chevy, Ford, Dodge. I already said Chrysler. Anyways, Toyota. These OBD2 connectors, their pin configuration is set by the feds, so that's standard. Anyways, so I would recommend one of those if you're worried about losing that memory. So even just disconnecting the battery on a modern car can be something that can be a little tricky. You know, there's been cars that, oh, it won't start again because now I've lost the theft control computer stuff, right? So that was my big warning for that. Some cars have insulation and stuff on their battery. They might have airflow, that, you know, all kinds of stuff. Batteries don't like to be real cold, but they don't also like to be real smoking hot either. So there might be some stuff. And of course, always start with a good, thorough visual inspection, right? So we don't need our meter for this. We just need, you know, a good flashlight maybe in our eyes, and just to really be looking for stuff, right? And I've mentioned things like this before. The battery hold down, that's an important thing. Like if the battery's just floating around in there, it's going to be exposed to more vibrations. So not is it a safety thing, but the battery's going to take a dirt nap on you sooner, meaning that it's going to fail sooner. So condition of the cables. Let me go back a few slides now. This slide. These are the classic GM side terminals, and they kind of stink. I mean, it gives you a lower profile design of the battery, but they are, generally speaking, kind of problematic. This one's all stripped out. I see people over torque these side terminals. Remember that this is tightening into a lead post. Lead is a very soft metal. It is easy to short these guys out, okay? So I'm always suspect of those side terminals. And you see all kinds of crazy stuff out there, man. It is amazing, some of the stuff you'll see. And I mean, it's almost shorting the positive and negative together. It was just like maybe an inch away on that C clamp. Like, I don't even know what, I mean, anyways, you see some crazy stuff. And notice that there's no hold down or anything on this either. So, you know, good, thorough visual inspection, clean all that corrosion off of there. You know, I've talked with other classes. Everybody brings up, oh, I watched a video. You can clean it with Coca-Cola. Sure you can, except it makes everything sticky and nasty. And, you know, that might be a waste of a good Coke if you're a Coke fan. If you're a Pepsi fan, maybe you don't care. But anyways, baking soda and water is better because baking soda will neutralize the acid where Coke will not, okay? So a lot of times I'll take a wire brush, I'll clean off the big stuff, and then I'll take my baking soda and water, mix it up into a strong paste, slather it on here, and just go take a break. Instead of pouring that Coke on there, I'll go drink that Coke and let the baking soda go to work on this thing, and it'll eat away all that corrosion. And then I wipe it down. I clean up the plastic case with some simple green, coat the battery terminals with some petroleum jelly, and or hit it with a battery protective spray. But get these things clean and tight to remove any corrosion, because remember, where there's corrosion, there's going to be resistance, and resistance is going to mess us up, right? If resistance goes up, current flow is going to go down. Now, battery connections. Again, this battery is actually kind of dirty, and look at the top of this battery. It's wet here, right? That's generally a sign that unless somebody's just washed the car or something, that's generally a sign that the battery is being overcharged, and that's letting out the hydrogen gas and some water vapor, and that's what you're seeing there. If you see a battery with a wet top, and again, it's not like somebody just washed their car or something, see a battery with a wet top, be very, very, very careful working around that battery. Do not make any sparks near it. I might get a fan blowing air over the car because that battery has been gassing. And if I see this, my tech tip for you guys is, if you see something that looks like this, what you want to think is, do I have a overcharged? I have an overcharge condition? Because usually what happens is if the alternator is charging the battery too much, it's too aggressive on its charge, it will basically boil the electrolyte out of the battery, and that will shorten the battery's lifespan. That can even make the battery blow up. So I've seen both of those things. All right, let's clear that out of there. So good thorough visual inspection, can't hammer it down enough, right? It's really hard to get the corrosion out of these things. Sometimes you're better off just to replace them, okay? Like if it's all like that, you can scrub this. It gets down in here in the molded plastic and stuff. You could try to take it apart. I'm a big fan for just replacing it because inevitably it's going to cause that failure when you're in like, you know, a bad part of town on a cold, dark and scary night or something. And when you most need it to work, that's when it's going to be a problem. So baking soda and water, right? Can't hammer it down enough. Again, look at that. This is pretty common for what you see. At least this guy's got a good hold down. This is pretty typical of what, you know, what you see out there. Okay. Here we've taken off the vent caps. Again, that would void the warranty on most, for most manufacturers these days. But what you'll see is that this battery has, see how wet the top is? This battery has been overcharged and we boiled out the electrolyte. Even if you added distilled water to this battery at this point, this battery's been overcooked. You can maybe kind of bring the battery back a little bit, but it's done. If this is your customer's car, just replace it and then also get into testing the charging system, which is what we're going to do right now. Now, I showed you guys this last week. I said, hey, the first thing we're going to do is we're going to hook up to the battery, measure the voltage. And we got a fancy name for that. We call it testing the battery's state of charge, right? Well, SOC, that term's used all the time, and we're using it more and more as we have electric vehicles and things where it's all about the battery, right? So that state of charge, it, you know, is important, and it's not a linear, I don't know if I spelled that right, but looks weird because it's all in capitals. It's not a linear scale. Let me show you what I mean. Not a linear scale. So 12.6 is 100% of charge, right? So you think, oh, well, that means 6.3 would be 50% of charge. Nope, look at that. If I'm down at 12 volts, I'm already at 50%, okay? This charge level goes up like that. It is not a linear deal by any stretch of the imagination. So when we measure the state of charge, we really want to be reading here at 12.6, okay? If we're down here, 12.3, 12.4, I mean, this battery's sitting here discharged. And then we have to ask ourselves, why is it discharged, okay? Maybe it's discharged because you sat there with the key on for too long, or you had the doors open and the dome light on. But you know, you want to ask yourself why and try to figure out the answer to that. So let's go back. So the state of charge is important. This battery's sitting here with 12.78 volts because he has a little bit of a surface charge on him, okay? Which is pretty common. If you have just driven your car and then, you know, the engine was running and then you shut it off and you check the voltage, you're likely going to measure over 12.6 volts, okay? Because we've stacked some extra electrons on the plates. What do I mean here? Well, let me fast forward a couple of slides and we'll come back to some of that stuff. Oh, where is he? He's in there. We're getting close. Let's see if I can change this screen share and get to what I want a little bit faster. There it is. I want these. Now, we saw that picture where we had a battery with low electrolyte level. That's electrolyte at the proper level. We looked at a battery and it was low, so it was here, right? But you can see those plates inside there, right, guys? This, by the way, is a built-in little hydrometer, but you know what? It's only testing one of the 6 cells. So this one cell could be good, but one of the other cells could be taking a dirt nap, right? And that would prevent the battery from working properly. So remember, like this old school battery has 6 caps here because there's 6 individual cells inside the battery. On each cell, it has various plates in there, and those plates are made out of a sponge lead and a lead peroxide. Lead peroxide is the positive plate, the PbO2. The sponge lead is the negative plate. Now, why would I walk up to a battery and maybe it's sitting above 12.6 volts? Well, because I've been driving down the road, the alternator has been charging. This circle's making this into an alternator, and it's putting extra electrons back on the plates. So I end up with extra negative electrons stacked on this guy. I end up with extra positive ions, right? Stacked on this guy, which are electrons that are atoms that are missing electrons. And so we end up with extra atoms, both positive and negative, stacked up on the plates. And because of that, we might walk up to this thing and we're measuring 12.8 volts. So I don't know if you guys remember what was my tip. If you're going to measure the state of charge on your battery, what are you supposed to do first? What are you supposed to do at the beginning there? If you walk over, it's sitting at 12.8. What should you do? What do you guys think? Throw a stick of dynamite under the hood? No, we don't want to do that.
I heard that you should just light the battery on fire.
Oh, there you go. There you go. No, what you want to do is suck off that surface charge, right? Turn on those headlights for 30 seconds or so, and then shut them off and let things stabilize out for another 15 seconds. And now look at what your meter is, okay? Your meter should be sitting here at a better value. Here we're hooked right up to the battery. You can see in this slide, in fact, I'll switch this back to a little bit better screen share here. Let's see. Hang on. I think I'm switching it back to the better screen share. Now we're there. So you'll see this thing's hooked directly to the battery. And we have the nice alligator clips on there. Man, I love having alligator clips so you're not having to hold it there, right? So it's clipped directly to the battery posts, and we're measuring 12.67 volts, and that's after we sucked off that surface charge, so that's perfect. I think the other thing to point out here is this battery does have some insulation on it. This foam piece on the outside is to help keep the battery insulated in cold weather. And then you can see the positive cable splits off in a couple different spots. Like this probably goes down to the starter. This one probably goes to the alternator. And this one's going to come around and go to your power distribution block over there. Okay. Anyways, it's sitting at 12.67. So that is a fully charged, 100% state of charge battery. So that's sweet. That's exactly what you want. But let's say you turn those it was sitting at 12.7. You turn the headlights on for 30 seconds. Now it drops down to 2.42. Ooh, now it's looking like the battery's getting a little shaky. Okay, so that's would be like one of our first signs that, hey, maybe this battery has lost some capacity. I'm going to keep going with my tests. In fact, what I'm going to jump into next is my available voltage test. So, couple notes here. If your battery is just dead as a doornail, right? Super dead, 2.2 volts, it's usually done, okay? You can get a charge on it, but it will likely keep dying on you, okay? If the state of charge gets too low, it's more than likely unrecoverable. Well, why is that? Well, that's because the way the chemistry of the batteries work, right? Sponge lead peroxide. There's one that's sitting there, is kind of low. Now we'll get back to the leakage test. 3-minute charge test. We'll get back to that test. I want those pictures of the battery plates again. There we go. Okay. So what happens is there is a chemical reaction here where as the battery gets more and more discharged, the O2 goes into the electrolyte and it becomes more of H2O. So it becomes more watered down, if you will. H2O from the O2 coming in there. The SO4, the SO4 gets absorbed into the plates, and so it becomes PbSO4, PbSO4. So basically what you end up with as the battery discharges, the chemistry on the plates change. And when we charge the battery back up, we're trying to reverse that chemistry, okay? But if this thing sits and sits and sits at a discharge state, the plates themselves, the lead sulfate, that PbSO4 is called lead sulfate, it crystallizes on the plates, and it's really, really hard to impossible to get the plates to reverse the process and basically break that crystallization and go back to what it's supposed to be, which is Pb and PbO2. So it doesn't want to switch. And so we call that sulfated. So if a battery sits for a long period of time in a discharged state, it's going to take lifespan out of the battery. It's going to sulfate the battery, okay? It's not going to want to charge. And even when you do get a decent charge out of it, if you can measure its state of charge, it's probably going to be way down in capacity because it can't change the material off the plates as easily or as readily, okay? So that's what we call a sulfated battery. PbSO4. Okay. So like a lot of the ARC school cars, they always have crappy batteries because they sit around in a discharged state, and all that does is sulfate the batteries. And so if we have a battery in there that should last 4 or 5 years, we're going to be lucky to get 2 years out of that sucker because of the conditions that we're putting it in. Batteries want to stay in a fully charged state, especially for a lead acid battery. Now, there's other battery chemistries, right? Nickel metal hydride in hybrid vehicles, lithium ion on newer ones and electrics. Those are a little different animals. A 12 volt lead acid battery wants to be at 100% state of charge for storage. Okay. So there are some tests that actually test that, this whole sulfation deal. You can't do this on all batteries. You can't do this on AGMs, but I'll back up a few slides because I blew over it. So if you have a battery charger at home, we'll get past that stuff. If you have a battery charger at home, that maybe looks like this, or something that's got an engine start feature where it can pump a lot of amps into the battery. And what we're talking about is 40 amps or more. There was an old school test called the 3-minute charge test. Again, don't do this test on a AGM, absorbed glass mat battery. But if it was a conventional lead acid wet cell battery, you would basically ram a fast charge in this battery, okay, for 3 minutes. And so you'd have to start this test. This is the test you would do, is like if you measured the battery's state of charge and the SOC was like at 70%, because it was reading like 12.3 volts, you say, oh, well, the battery's kind of discharged. It needs to be charged. I'm going to ram a 3-minute charge test down its throat. So you hook up your battery charger and you hook up your voltmeter to the battery voltage to see what the voltage is while it's being charged. Okay. So it was a super easy test to do. It required you to have not only a voltmeter though, but a fast acting charger. So at the end of the 3 minutes, before you turn off the battery charger, you would just look at what does my voltmeter read. If my voltmeter was reading less than 15.5 volts, that was good. Give it the green thumbs up. Okay. But if the voltage was above 15.5, that's going to get the thumbs down. In that, what we're saying is that this battery is now sulfated to the point where I'm trying to charge it. I'm trying to quickly reverse this process, and it's fighting me. It doesn't want to reverse that chemical process, and that's telling me that it's sulfated. A good battery that's just sitting at a low state of charge, you could hammer it with some amps, and it would take those amps, gobble them up, and reverse its chemical process, okay? A battery that is sulfated is going to fight the battery charger and not want to reverse its process. And so what the battery charger is going to do is he's going to cram his voltage up higher and higher, 15.5 volts, 16 volts, maybe 17 volts, as the battery charger is trying to ram the 40 plus amps into the battery, and the battery's not taking it. Okay. So that's that 3-minute charge test. Again, it doesn't work on a lot of modern cars with AGM batteries, but for the cars that have a conventional battery, this test worked pretty good. And it's something that maybe you could do as just like a do-it-yourselfer at home, because it's always good to have a nice battery charger around your house. And if you have your voltmeter and a nice battery charger, boom, you can do this test. Okay. Really, really good test, especially if you walk up to the battery and you measure its state of charge and the state of charge is low, jump into a 3-minute charge test. Okay. All right. But let's say the battery state of charge doesn't seem that bad. Well, what can I do? What can I do next? Well, there is some other tests I can do. I'm going to switch this to this slide so we can see a bunch of stuff. Like I showed you a deal where we were, you might have had a, if you had a load tester, what this would do is it would actually pull amps out of the battery. You were basically creating a short across the battery with this carbon pile element, and you could dial in however many amps you wanted. In fact, what we would do is we would pull the amps that we wanted based on the capacity of the battery. So you go to 1/2 the cold cranking amps. So if this battery was rated at, let's say, 600 cold cranking amps, I would load it down to 300 amps, and I would turn this big old knob here, load it to 300 amps for 15 seconds, and see what happens. Okay. But this was an expensive tool, and you're not likely to have this in your home garage. And not only was it an expensive tool, these carbon pile elements, these things would wear out, and you'd have to work on those and replace those. You could damage a battery by putting too much load on there. There's also not like a handy dandy printout coming out this thing. Like, you have to know how to use this tool, how many seconds to put the load on. You have to take the CCA and cut that in half. I mean, you got to have some skill here. And, we're definitely these days, we are in a world that has an absence of skill, right? So we've gone away from these old school ones, and we've gone more to these ones where you punch in the information and it does a lot of junk for us. And of course, our customers, everybody loves getting a printout, right? You see that printout? You know what that is? That's money, guys. That's money right there, man. People love a printout. My old alignment instructor from years ago, really cool guy, Jack O'Donnell, he actually had alignment shop for years and years. And, before the computerized alignment machines, they were just starting to come out on the market. And those early alignment machines, they weren't very good at all. And he's like, those things are garbage. And so, but he realized that people wanted this printout from these new computers. So he would do all his manual gauge readings, and he bought a little word processor, and he'd have his office staff type it all up into like a special fancy looking word processor sheet so he could give his customers a printout. And then in doing so, he was able to charge another like $30 in alignment or something. Anyways, people love a printout. They don't care what we have to say about it. The computers, those are smart. So this is what most shops will have these days. In fact, it's to the point now, if you're working at a dealer, you're going to use a machine like this that is specific to that manufacturer. And to actually replace a battery, you have to test it with this machine, and it has to, spit out some type of special warranty code. It gave me an XJ72 code. And so now I can get that battery replaced or something silly. Anyways, why? Because they would find that, honestly, even factory dealership technicians would be replacing batteries that didn't need to be replaced. And then you get into, well, did they just not know how to test the batteries properly? And I think that's part of it. I think the other part of it was how we got paid. Back in the day, like in my day working on cars, we got paid by flat rate. And that was largely by doing repairs on cars. So I didn't make any money really charging up somebody's battery, but I can make a half hour or something replacing the battery. So what was your incentive? It was like, well, the battery's kind of low. I could dork around with this thing for an hour charging it, or I could slam a battery off the rack off of my battery rack in this car, give the customer a new battery, and make some money off the deal. So I think it was more about maybe the way we were, compensated for what we did. But anyways, you're likely to have one of these testers. This tester, if you look at the leads on it, you can see that, okay, there's no way that this tester here is sucking 300 amps or anything from this battery. That's not how those work. They don't actually put a load on the battery. So in some ways, this old school tester here is better because you can actually pull the amps out of the battery and see what it's really going to do. Okay. If that thing's, rated at 600 cold cranking amps, let's see if it can do half of that. Right. These don't do that. What they do is they actually test the battery almost like a big ohm meter. They're a resistance capacitance tester. Here's another popular style. This one's by Midtronics. Midtronics is one of the leaders of battery equipment. And I found these things like they're pretty good. You can, when used correctly, and they're 90%, which is probably, a whole, 20-30% better than the average guy that didn't know how to use one of these things properly, right? So this is what shops will have, and what it does is it measures the internal resistance of the battery and all those plates and stuff on the inside. The battery's internal resistance changes as the battery becomes sulfated. And so it uses that and the algorithms that are programmed into the tool to figure out what is the life of the battery. And what you'll get from this thing is a printout, and it'll say it's SOC, which, what's SOC again, guys? What does that mean? It's the state of something.
Charge.
Exactly. State of charge. But it will also give me usually like a little graph or some type of printout of the SOH. So it'll say, oh, your SOH is at, I don't know, maybe 90%. And here's a little smiley face. SOH is your state of health, okay? And people love that. That's like a good term that people can relate to. So most shops these days, unless they're an old school shop, will have this style of battery tester, and it works pretty good. There's sometimes where it's frustrating because you hook it up to the battery and it says, oh, the battery's discharged. The state of charge is too low, and you need to charge the battery, right? And then I'm like, okay, I'm going to jump into a 3-minute charge test. And sometimes I've had it say that the battery was good when the battery would fail an actual capacity test from one of these old school testers. So I have found, there's times where the new fandangled ones will miss some issues, but they're pretty good. And that's kind of what we have. So I did want to point out though, look at the leads on this sucker, right? These are big, fatty leads here. This can pull 300, 400, 500 amp draw out of the battery. This guy or this guy cannot, right? So it's just a different deal. So this test is called the available voltage test, because I'm going to go out on a limb and I'm going to say, hey, you might not even have a battery charger at home. You certainly don't have one of these guys, but you know what? You could probably go to your local auto parts store and ask for their free battery test. And those guys are probably going to pull out a tester similar to this or similar to this and test the battery. So whatever tests you guys do with me in this class, I would recommend you do that just to kind of compare things, right? Like if you go to the doctor and the doctor says, oh, you got, 2 weeks to live, right? You're going to go get a second opinion, right? So, I think it's always good when you're doing diagnostics on a car, nothing wrong with getting a second opinion. Use other tools, other testing procedures, and kind of go with the combination of those to figure out what's going on, okay? So if all we have is our volt ohm meter here, right? Let's say all we have is this guy right here, and we've hooked him up to the battery. A test I like to do is the available voltage test. Now, the battery starts out, I do the state of charge. Oh, it's 12.6, that's looking good. Okay, now I'm gonna crank over the car and start it. And when I do that, the battery's voltage is gonna drop. Why? Because remember, a battery is an electrochemical device, right? We're taking a chemical reaction of lead and acid, and we're using that to produce, a charge, and then to get, we give it a circuit there, and then we get electrons flowing, right? So what happens is when you start to crank over your car, you're putting a pretty good amount of load on that thing. So current's flying out of this positive side of the battery. If we think conventional current flow, it's flying out of that positive post and it's going into the negative post as it travels through our starter motor to crank over the engine. And when we're using our starter motor, it's going to pull quite a bit of amps. It's going to be somewhere between 100 to maybe 200 amps. So there's usually nothing else on the car that is going to pull more current out of your battery than the starter motor that's on the car. Okay. So because this is a chemical reaction and we're sucking so many amps out of this thing, what happens is it's kind of like, remember how we related to electricity to water, and voltage is the water pressure. So here's the water tower, and if you lived in some old farm town or something, we'd use a big water tower, and the water's up here in the tower, and that gravity and the height of that tower is what creates our pressure, right? Well, if we have, every spigot on this water tower is open and a ton of water is flowing out of this thing, what's going to happen to the pressure? It's going to drop, right? So that's what happens here, is because we have so much flow, so much current flow, that the voltage is naturally going to drop in the battery. Okay, that's how it's going to happen. So what we're going to do is we're going to see, well, how much does the voltage drop down to as I crank over the engine? What do I want it to stay above? I want it to stay above a good amount so the computers and stuff on the car can still work correctly. So let me go to this available voltage test. I want this thing to be above 10.5 volts. So what are we going to do here? Let me put up my text tool here, and we're going to add some notes on this thing. Did I have that up here? Oh, I thought I did have all the steps. Oh, no, maybe I didn't. So we'll put it right here. So I want this thing, as I crank it over, what I want here, guys, is I want so I want to, oops, let me, oh, now my things got in there with that other stuff, but I want to crank over the battery. I want to crank them over for about 15 seconds. Now, I don't want to crank it over for 2 minutes or 30 seconds even, because a starter motor gets really, really hot when you're cranking it over, okay? You would get hot too if we were pumping 200 amps through you, right? So I don't want to burn up the starter motor, but I want to crank it over long enough to get a decent reading and to see if things kind of stabilize. If I have a battery that's losing capacity, it might be able to stay above 10.5 volts for the first 5 seconds, and then it takes a nosedive after that because it runs out of capacity, okay? So I would like to crank this thing over for about 15 seconds. During that time, I want the voltage to stay above 10.5. Well, why 10.5 in particular? Well, 10.5 happens to be a pretty good voltage threshold for most of your computer systems to operate correctly. And what you see is when the voltage drops below 10.5, the computers start to make weird calculations. They might start to compensate for things. They might not even turn on. And so you might get a computer with that. And I've had this happen multiple times where I had a car that it cranked over, and it cranked over a little slow, and it just wouldn't start. What the heck? And you put a jumper battery on there or give it a jump start, and it cranks over a little faster, and it fires up. And you're like, oh, what's going on? Well, it's, yeah, you have the slow crank going on, but it's likely related to that the available voltage. Think of this available voltage to what? To the computer. Okay, I'm going to put PCM, Powertrain Control Module, using my good OBD2 terms.
Mr. French?
Yeah.
So on the homework, I tend to do the homework early if I can because I'm busy with work.
Yeah, that's fine.
I went ahead and submitted a video of me doing that, but I didn't do it the 15 seconds. I just cranked it and then read the lowest voltage, which was 10.86. Do you want me to go back and then
No, that's
do it, or is it okay?
no,
to,
that's okay. Just make a note. If you make a note down that you realize that you should do it for 15 seconds. Now, here's the hard thing with this is most of you guys probably aren't going to be able to do it for 15 seconds because what's going to happen, the car's going to start up before you hit 15 seconds, right?
Unless you
go ahead.
You could disable your fuel, and then that could.
That's what I was going to get to is to really do it and have the car not start. What you'd have to do is you'd have to disable your fuel system or possibly the ignition system. And so you'd have to disable some stuff to kind of rig it so that it doesn't start up in 15 seconds. And or that you could crank it for that 15 seconds and really get a good test. Now, I'm not going to really ask you guys to do that because, you start disabling stuff. I don't want any of you guys to mess up your cars. At the very least, you could end up setting some codes. I don't want that headache there. But I want you guys to know if you're really going to do this test correctly, you should crank it over for 15 seconds and see how low the voltage goes. And we really want it to be over 10.5 volts. So on this one, we had some results, and thank you, Sam, for bringing that up. So just make a note, like, yeah, I only cranked it over for 5 seconds and it started. And this was the lowest the voltage went. Obviously, if in 5 seconds it's dropping below 10.5, I'm not real happy with this battery. But there's a couple of things that could be going on. Okay. So look at our results here. This one, we cranked it over at the battery is 10.76 volts. At the starter is 10.12 because there was a little bit of voltage drop in the cable. This available voltage is above 10.5, and I'm happy with that. What I'm not happy with is that we are dropping over a 0.5 volt on the starter cable. Now, I wouldn't have you guys do this part because a lot of cars to get to the starter motor, you might have to get underneath the car, and we're in distance learning. And I don't really want you guys jumping underneath your car and doing a bunch of stuff, especially if this is new to you. I guess if you have all the equipment, you have good jack stands and stuff at home, and you're gung-ho, you've taken other classes and stuff like Sam has, you're welcome to do that stuff, but I'm not going to require you to do it. This particular car actually still started, but cranked over a little slower than we felt like it should. And it ended up having corrosion on a cable that was causing it not to start. And here we're doing voltage drops of all the various spots on the cable and working our way down. Well, that's another battery, but we're working our way down to the starter. So anyways,
question, sir.
Yeah, go ahead.
If you can get the video,
Yeah.
for me, I'm trying to figure out how I would download it. I guess I would have to send it to myself in Gmail, and then maybe hopefully save it to a PDF or something. Do you have any suggestions on that?
So you can submit it in a regular MP4 format. If I let me change the screen share here.
I just submitted it as just one, and then I wrote the results in the comments for the rest.
That would
smart.
be fine.
Yeah.
But do a quick video. Don't make it too long, because if the file gets too big, it gets real clunky loading it and everything. So that's why I said like 1 minute or less. Like,
even send it if it's a big file.
If it's real big, well, Canvas will allow you to submit it. So if I click this thing, and click submit, and it's I must attach one.
Yeah,
so I got to go in here and I got to grab a file. So like that's a huge file. It's like an hour-long class. I can actually click submit and that thing will load. It'll just take forever. Okay. So Canvas, it's not like trying to email something where you're really limited on stuff. I'm sure there is limits, but if the video is reasonably short, it will allow you to submit it that way. But yeah, Sam's right. Like, choose the file, click submit, and then you can go over here and say text entry and say, these were my readings, right? And
that's awesome, guys. That's awesome. Thank you.
Yeah. So it's, it's a little bit more clunky than if we were in regular class, right? But when you see the confetti, you've submitted your stuff. You can always go back in and resubmit. Like if Sam wanted to add some notes, that's fine. The idea is getting you to do some stuff and thinking about some stuff, right? So that's that activity. We're measuring available voltage. So let's see if I can get back to that spot where I was, and I'll change my screen share. Hang on. Boom, boom. All right. So we're, we really haven't changed the position of our leads. We're just here on the battery, and then we crank it over and we see, well, what did it drop down to? So let me give you some ranges. Because we're just looking at voltage, we're not really seeing the full story, okay? But we can kind of infer the rest of the story, okay? What do I mean here? Well, let's look at one of these old school testers. I don't know why I can't find the pictures I'm looking for in my own presentation, but I never seem to be. There it is. Okay. Actually, I'll use this one. This old school tester had the ability to measure several hundred amps and measure what the voltage was. Okay. Well, our meter, even if you have, whether it's a Harbor Freight meter or this $400 Snap-on meter, these guys can only measure voltage. And as far as amps, well, this guy can measure up to 10 amps, but that's not going to cut the mustard, right? That's not going to get the job done. So we're only looking at volts, and it doesn't necessarily tell us the full story. So let me talk about the amps real quick. And I might have said this to you guys before, but anyways, it's good to go over again. The amps vary. So I'm going to say cranking amps. Cranking amps vary by engine and starter design, in that some new starters are permanent magnet starters, so they're a little bit more of an efficient starter. Maybe they're permanent magnet gear reduction versus your old school starters that would weigh like 50 pounds. Those will generally pull more amps. So I will say, like, if the starter looks smaller and it's physically lighter in your hands, it's going to be a more efficient starter that pulls less amps. But it also varies by the engine, right? Because we could have a V8 engine, a V8 that's, 454 cubic inches, or we could have a V8 that's, I don't know, maybe it's, 4.6 liters, right? Like, that's a pretty big difference in size of two V8s, right? I could have a 4-cylinder. I could have, so again, the bigger the engine and the more cylinders it has means the more pistons you have in there with their rings rubbing on the cylinder walls, right? So more cylinders generally is going to equal more friction, and that means it's going to take more amps from the starter to crank it over. So we're going to make a little chart here, and what we're going to say is, I'll put V8, but it could be, I don't know if you'd be working on something that's an 8-cylinder that's not in a V, but so V8 is anywhere from maybe 150 to 250 amps, okay? If I have a 6-cylinder, now this could be a V6, could be an inline 6, right? But it's going to be a little less. So it's generally going to be in the range of 125 to maybe about 185 amps, okay? 4-cylinders, well, again, it varies by their displacement, like how big they are. So for 4-cylinder engines, you might see something with a low compression motor that might be as low as like 90 amps, but some of these might go up to like 130, 140 amps. Okay, so it varies by the size of the engine in the car and the efficiency of the starter, okay, of what it should draw. Now, if you have the right battery in the car, right, it's got the right cold cranking amp rating and all that stuff, then, if that engine is designed to draw, let's say it's a V8 and it's designed that it's going to pull 200 amps, well, then the battery should be adequate on its specs that it can handle a 200 amp load for 15 seconds without the voltage dropping below 10.5. Okay. So even though we only see the volt side, we can kind of infer what the current is doing. So let's say we go to crank over our engine, and it cranks over kind of slowly, and the voltage drops down here, and it does start, but the voltage drops down to like 9.8 or 10 volts. It's dropping down low. And I think, ooh, man. Well, I have one of two things happening here. I either have a tight engine, so I'm sucking too many amps out of the battery, or I have a battery that is low on capacity. Okay. I have a battery that's low on capacity. I have a battery that's starting, its state of health is starting to go down. Okay. So how could you figure that out? Well, and then I guess there's actually a third deal. You could have a starter motor that's starting to short out. And so the shorting out of the starter, right? The starter's internal resistance is too low. So the current flow is too high. So I'm sucking too many amps out of the battery. The battery cannot supply me with that. So, you know, I don't see the whole story. It would be better if I could measure the current flow. But if I was going to measure the current flow, I'd have to spend more money. I'd have to have more than just a meter. I'd have to have some type of amp clamp. So I have an amp clamp here. I'm going to show you. I've showed you some of these guys before. This is my old one that as soon as I got it, I didn't like the lead was on a coil thing and it got all screwy on me. But so here's an amp clamp. Now remember this picks up the magnetism around the wires. This one goes to 600 amps. So I would clamp that around the positive or negative battery cable, but I usually would pick the positive that was going down to the starter, and I would turn this thing on, and what it would do is it would pick up the magnetic field around the wires, convert that into a voltage that I could then read with my meter, right? So if you look at this thing, and I'll zoom in on the bottom of it here. Get that text up there. So 600 amps, output 1 millivolt per amp. Okay. So if I was measuring 100 millivolts on my meter, that means that 100 amps would be flowing through that battery cable. Okay. So, you know, it's a current clamp. Now I showed you this current clamp before, which is super handy. It's made by the same company. I don't think they're around anymore. So this one goes to 60 amps. So this is my low amps probe. This is my high amps probe. Anyways, so if I put an amp clamp around the battery cable and I had maybe a couple of meters, I could measure the volts and the amps at the same time that as I'm doing this test. And then I would know the full story. Oops. Now let's see. You guys might not have seen any of that, huh? Because I don't know if I changed the screen share. Gosh darn it, guys. You gotta tell me if there's something doesn't seem right. Let's try that again. Let's try this again. So I'm screen sharing. Okay. Low amps probe. This one can do 60 amps. Going the wrong way. This one can do 60 amps. This one could do 600 amps. And the idea is that you clamped him around the positive battery cable, or you could do the negative cable. You had to watch make sure you were fully clamped around the wires and pay attention to your polarity. But you clamp him around there, and what he would do, again, is he would change the magnetism that he measures into a little voltage reading off of the 9-volt battery that's on the inside of this thing. And the scale here is set up so, if I get them on the screen, 1 millivolt would equal 1 amp. So if I was measuring 200 millivolts, that means I would have 200 amps flowing through the cable that was going through this clamp. When you use these guys, you got to make sure that this thing clamps down all the way. If this thing's open, like maybe it's at an angle, it's not all the way closed, it'll throw off its readings quite a bit. Okay, so if you had one of those, you could measure the volts and the amps at the same time as you did this available voltage test, and then you would know the full story there. See if I can get back to where I wanted to be. Okay. And so if it was pulling way too many amps, what you would see is that the battery voltage would go down because you're pulling way too many amps. And then if you go, well, I'm pulling too many amps, I either have a tight engine or I have a defective starter motor, right? So from there, what you could do is physically get a wrench on the engine and see if you could spin the engine. If the engine spins normally, like it doesn't take like both your arms and legs to actually turn the engine with a big 1/2-inch ratchet, then, if the engine feels good, then it's probably a starter motor that's shorting out. What I would do if I only had the voltmeter and I was doing this available voltage test, if the voltage dropped below 10.5 volts, if I had a wrench, I might spin the engine. If the engine felt okay, I would think, okay, well, either I have a weak battery or I have a starter motor that's shorting out, right? Well, now I could see, well, what's the battery state of charge? Maybe I could do a 3-minute charge test on it, or I could go over to my local auto parts store and have them use their resistance capacitance tester on it and see what that thing said. Okay. But at that point, I need a little bit more tools to kind of make a better decision. But if it cranks over quickly, like the cranking rhythm and speed sounds good, it sounds crisp, it's cranking over nice and sharp, and my voltage stays above 10.5, hey, I don't have to do anything else. Like, that's a pass. Like, this thing's looking good. Okay. So available voltage test, that's one of the things you're going to do on your worksheet. Okay. Now I have some things here like using a refractometer and measuring the electrolyte, specific gravity of the electrolyte in the battery. Again, I'm not going to get into this stuff because nowadays, if the battery manufacturers say, hey, if you take this battery and open it up, we're going to void your warranty. So this is kind of an old school thing that we used to do, and it worked good as long as you didn't get battery acid in your eye or anything. But it's kind of something that's not done as much anymore. And a lot of batteries are sealed. You can't take those suckers apart anyways. All right, so what's the other part of this lab? I am going to go back to the lab, and it says, after you crank it over, let it start and run. Now do a voltage output test. Okay, so let's close that. We're gonna put this one up here. Okay, so we're running a little long, and I don't want to take the time to fully go through every one of these, but just an overview is that how an alternator works, right? And here we have a nice little alternator cutaway. Is an alternator takes power from the battery and makes a magnetic field inside the alternator. Then it takes some horsepower from your engine, and it uses that mechanical horsepower to spin this guy and the magnetic field that's in there to generate more power. So you've maybe heard the expression, it takes money to make money. Well, here we have, it takes power to make more power. Okay. Where's my power for coming in? Well, it's coming in from the form of electricity from the battery and some horsepower from the engine. And I put those two things together to charge this battery back up. Okay. So the drive belt's got to be good. The alternator's got to be in good shape. Visual inspection, we'll hit this stuff more and more. But here's we're measuring the output with an amp clamp. Current draw voltage testing. Okay. So here's what we're going to do is we're going to start our car. Right? We cranked it over. It was above 10.5. Let's say we start the car. We're going to rev it up. And what we should see is the voltage should be, I like to keep numbers even. So what rolls off the tongue for me really easily is 13.8 to 14.8. Most stuff will be 13.8 to 14.8. You might find some cars, especially if the battery is hot, the ambient temperature is really hot outside, that it's low as 13.5 because some newer cars actually compensate for temperature. And you might see those same cars, fancy newfangled cars, they might be up as high as 15.2 volts when it's cold. A battery can accept more charge when it's cold. It can't accept as much charge when it's hot because you're likely to boil the electrolyte out. So new charging systems are getting more and more sophisticated. Okay. But what's kind of the average? 13.8 to 14.8 volts. Okay. So that battery should be 13.8 to 14.8 because now the alternator is charging the battery. Okay. If everything's working correctly. And then I'll let the thing idle down, and I'll want to make sure that it's still above 13 volts or so, even when the engine's idling. And I can start putting some loads on. Oops. Voltage regulation. I can start putting some loads on there, and I can see, well, you know, if I turn on the headlights and the air conditioning, does the voltage still stay above 12.6 volts, so at least the battery's not getting discharged? If it does, that's an indication that your charging system is working a-okay. All right. But if you turn on your all your accessories, let's say you turn on your headlights on high beam, and you got your rear window defrogger on and the radio on, you turn on a bunch of stuff, and you even rev the engine up to 2000 RPM so that the alternator is spinning faster on the inside. You rev it up, and it's not able to maintain voltage above 12.6 volts, like it's low, then that would indicate that I have a charging system issue. Okay. So the lab work is basically pretty darn easy and can be done really in a matter of minutes. You hook up to the battery, just like you can see the guy in the picture here, crank over the car, see what the voltage drops down to, and then see what it fires up to once the engine starts up and starts running, and rev it up. And it should be, most cars, between 13.8 to 14.8 volts. And that'll kind of get you going the right direction as far as the overall, like an overall quick test of your battery, starter, and alternator is really just doing that. State of charge, available voltage, voltage regulation is the three things that you've done there. Of course, when you say them all out, it sounds a lot high tech, a lot more high tech, but it's pretty quick and easy to do those things, you know. And then if something didn't seem right, that's going to require more investigation. So let me switch this tab over, and I know I have all kinds of stuff going. Let's see here. I'm going to go to this guy, so that cleans up our screen a little bit. And minimize some of that. I'm just doing a little bit of housekeeping. Okay, I had opened up CDX in the electrical section, and I went to the media gallery, and just to show you an electric motor on the inside. Electric motors are awesome. Electric motors basically take electricity and use electromagnetism to make this thing mechanically move, right? So there you have electricity going in, electrical energy, and you have mechanical energy coming out of this thing, right? Your starter motor, like what you see on this slide here, would use brushes. So at some point, it's going to have an armature and a commutator that controls the power flowing through the motor, and it has brushes that are sliding on the surface of the commutator as the starter spins. So that's why if you have a starter and you know it's getting old, well, at some point the brushes will wear down the little nubs, and now the starter will get high resistance, and it'll start cranking slower and slower and slower. Okay. Or sometimes the starter gets so hot the wires on the inside start to short out, and now it's pulling too many amps. But I wanted you to see this animation of how an electric motor works. These are brushed motors. The electric motor in like a hybrid vehicle, like a Prius or even a Tesla, those are going to be brushless, and they're a whole lot more fancy on the inside. Is how do you get the electricity in the motor without actually having a direct mechanical connection? It gets pretty amazing in there. But a conventional starter motor in your car, it's a brushed motor. Okay, so here is that starter motor circuit. And you know what I like about this drawing here is it utilizes the relays that we were going over last week. So I turn the ignition on. Let's see. I guess there's not an on, it won't let me just turn it on, but I can go to crank. You can see when I go to crank, what does it do here? Well, if I get my annotation tools up, I was thinking about it. That allows power to go through the control circuit of the relay. It then makes a magnetic field on the inside, which closes the relay contacts. That then allows power to go from the positive side of the battery through the relay to the starter solenoid. The starter solenoid then engages, and then that lets a large amount of power, this is the 100, 200 amps, to go through the big fat battery cable into the starter solenoid, through the starter solenoid, and into the armature and windings of the motor and spin it over. So it's almost like you have two relays here. You have this little starter relay that controls the power to the solenoid. Then you have the starter solenoid that controls the large amount of current. He's like a heavy duty relay that does two things. Not only does he control power going into the starter, but he also is what actually engages the starter. So if I turn off my, if I clear my drawings and I make it so that I can turn this thing off now, okay, you can see that it's the solenoid that causes the engagement. So it's like a heavy duty relay that also creates magnetism and moves a plunger to engage the starter drive. So he does two different things on there. Okay. What that also means is that you could have a car not crank over because maybe the little starter relay has failed, right? It could be as simple as that. Or it could be a starter solenoid issue, and oftentimes it is. Oftentimes what I will have happen is I will develop a bunch of corrosion from arcing on the inside of the solenoid, and then I have a voltage drop across the solenoid contacts. Back in the day when we would rebuild starters, a lot of it'd be like, if you're rebuilding a starter, put a new solenoid on it. These days we tend just to change the whole starter out, right? Let's look at some voltage drops as we kind of wrap this thing up. I'll clear these drawings. So this is a pretty cool graphic. We can see what our battery voltage is, see where the meter's hooked. So, that's 9.8 volts. That would fail my available voltage test, because that means the computer systems now are only getting 9.8 volts, and they might not be too happy with that. Let's do a voltage drop on the positive cable. Boom, that's how we would hook up our leads. So we're dropping less than a half a volt. That's good. I don't want to drop more than a half a volt. Voltage drop on the negative cable. Same thing. That's kind of high for a negative side. I'd like it to drop less than 1/10 of a volt. So between this side and this side, we're almost dropping a half a volt. That's still an acceptable amount of voltage drop, so that's okay. Voltage drop across the solenoid, across the switch circuit, or so that's the switch voltage, across the relay, and then we got some hold-in winding testing that they're doing, which is a little weird, but they're testing the solenoid. Remember, resistance test isn't a great test, but you can see some of the different connections you would do. The big ones that we do these days is we do, hey, what's the battery's voltage cranking over? And then we go, well, what's the voltage drop across the positive cable? Oh, okay, if that's okay, and that's okay, and it's got a good battery and it's cranking over slow, I'm throwing a starter in there, okay? All right, so let's finish this class off tonight, because you guys kind of know the assignments for this week are the discussion on electric vehicles, and there's a couple things about your meter, little quizzes and stuff. This stuff on starters and stuff is really due next week, so you have a little bit more time to get that stuff done. But I want to finish tonight with a diagnostic story, okay, with a case study here, if you will, and I'll keep this graphic up on the screen to do it. So we're looking at the starting circuit here, but let's put a car on this. This is, let's say this is a beautiful green Cadillac DeVille. Okay, so here's my Cadillac story here. So this is a Cadillac, and it came in, car won't start, and it actually doesn't crank over the engine. It's a click, no crank. So you turn the key to start, right? You could turn it to crank and it goes click. You let go of the key, it stops. Click, click, click. So that's important, because you can have different types of no starts. You can have no click, no crank. You can have click, no crank, or you can have a car that cranks over, but it won't start up, right? I mean, those are three different scenarios. So we have a click, no crank, and I'm going to write that up here. So at our shop, what would happen is stuff would only come to me after 3 other guys looked at it and screwed it up, okay? I mean, that's just how it worked, because I was always very busy doing diagnostics, and if it appeared to be something that should be easy to figure out, that wasn't going to go to me. That wasn't worth my time. That went to the other guys. Okay, so we have a Cadillac, or cataract as we used to call them. So we got a CAD, and it's a click, no crank, came in on the hook, meaning that it came in on the tow chuck. All right, so our first guy looks at it and he's like, oh, okay, click, no crank. Well, you know, makes that click noise. It's got to be a what, guys? What part does this guy want to hook on this car right now? What would you want to put on there? Remember, back in the day, mechanics got paid to put parts on cars. So, okay, yep.
Battery.
Battery, perfect. I think we actually replaced the starter first, because that paid more money. But well, so the guys, they replaced the battery. They also threw on a starter. And guess what? It was still a click, no crank. So, what the heck's going on here? Click, no crank. Well, you know what? We must have got a bad starter, right? So, like 3 starters later, now it comes to me, because, yep, it's screwed up. Something's going on. So I took my meter and I took the amp clamp, and I tested the voltage, the available voltage, and the current flow at the same time with 2 meters. And this thing was pulling, like, the battery voltage was dropping down to like 9, okay, which was bad. So I'll put that on here. So avail voltage went down to 9 volts. But, and you think, well, maybe the battery's bad. Oh, we put a new battery in it. You know why it went to 9 volts? Because this thing was pulling like 600 amps. What's going on? Well, it's hard to believe that 3 starter motors are bad, right? What has to be going on? It can't be high resistance in the cables and stuff. That, you know, and that's what I had other guys saying, oh, well, you know, maybe we got to put new battery cables on there. The cables are bad. And it's like, okay, now wait a minute, guys. Think about this. Ohm's law, right? We got a 12-volt battery. We're pulling a ton of amps. So that would tell us, hey, the ohms are too small. Now, why would the ohms be too small? Because the starter motor can actually crank over the engine. Before the starter starts spinning, it's almost like a dead short. And once the starter motor begins to spin, that's when it starts to develop its own internal resistance, which is based off that counter electromotive force phenomena I was talking about earlier. So if a starter isn't allowed to actually spin, and if electric motor is not allowed to spin, it pulls a lot of amps. you guys who are electric vehicle buffs, you've probably heard about how like Teslas are pretty fast, right? And how electric motors make maximum torque right out of the hole. That's because when the electric motor's not spinning, there's no CEMF, and so it pulls a ton of amps. That's what this thing was doing. So what was the deal? Well, had to be a tight engine, right? So I put a wrench on the crankshaft and I went to spin the engine, and I put my whole body weight on this thing, and I could not move that engine. I mean, that engine was solid. So no wonder it was a click, no crank. The starter motor would try to engage it and spin the motor, but it couldn't. And so it just stopped it, pulled a lot of amps, sucked the voltage down. Okay. So if you had a car with a tight engine, would you just be like, the engine's tight, throw a new one in there, give me $5,000? What would you do before you just, condemn the engine, guys? What do you think? Let's put that Cadillac back.
As far as it not starting, you mean?
Yeah, it's not starting and the engine's tight. I physically cannot move the engine with the wrench, right?
Oh, in that case, yeah, you better go over and get yourself another engine.
Yeah, so this thing doesn't start because the engine physically can't turn. What I need to do is look at everything that turns with the engine and make sure that other stuff isn't locked up. So I check the oil level. Now, if the oil was bone dry, I'd be like, oh, maybe they did seize this engine. But this car was well maintained. An older couple owned it. I mean, the thing was cherry. It had like 20,000 miles on it. So what I did is I started process of elimination, taking stuff off. And I actually took off the serpentine belt. And when I took off the serpentine belt, now I could crank over the engine by hand. In fact, then I was like, oh, well, with the belt off, I'll see if the starter motor can fire up the car, and I could hit the key and boom, it'd fire right up. I couldn't run it very long because nothing's spinning the water pump at that point, right? But I confirmed that, hey, the engine can start and run, so the engine is okay. The starter motor works, the battery works, like
So
everything's
the alternator
okay.
was frozen?
Something is frozen. And so then it goes down. Once you have the belt off, just spin all the pulleys. And what we found is that this car had an air injection pump, and the air injection pump, or smog pump, as a lot of people would call it, was frozen.
Oh.
And because the serpentine belt, it's about a 1-inch wide belt. And it was in good condition. They did all their service, so it had a nice belt on there. Because a serpentine belt has so much darn grip, that smog pump or air injection pump, that being frozen basically made the whole engine frozen and kept the car from starting. So anyways, it was one of those things. Oh, the car doesn't start, replace the air injection pump. Like if you said those two things, one right after another, it wouldn't make sense, right? But when you went through the whole process and, first started with your electrical tests and then kind of went from there, you could put the puzzle pieces together and figure out what was going on. So you'll see weird scenarios like that as you begin to work on things. And we have, more unique things going on as cars have gotten more and more sophisticated. But this available voltage test, it's a good one to do because it can give you a lot of information in a very short period of time. So next week, we'll kind of continue on this theme, and we'll go over some charging system stuff and look at another couple case studies related to that, and then start to move into some like total circuit wiring and stuff on our vehicles, and kind of finish off our class with more case studies where we're using our meters. Now, I think some of you guys are probably interested in, like, what I want you to do is do this available voltage test and voltage regulation, where you're, do it on your own cars, make those recordings, do that type of stuff. Then if you want to jump ahead, I have a video clip here that I took of the race car sitting on the side of the house. And I originally planned for this just to be like an example, and it was a car I had handy at the time to test. But we end up with some unique, weird readings on here. And so the activity here is that I test this thing, but I show you the meter readings, but I don't tell you what's good or what's bad, or so you have to look at the meter and make a determination. Oh, that's what the meter reads. What's the state of charge? So if you want to kind of get into some diagnostics, you can kind of follow along on this video clip here, and figure out what's going on. I'll make sure that I take this link here and I'll copy it and I'll put it on our class announcements. Okay, so for you guys that want to play around on that stuff. Okay, that is all I had for you tonight. I'm sorry we went a little bit over, but it's a pretty fun subject area, and I like to kind of share these diagnostic stories with you guys so you can see what my thought process is and how you kind of do that process of elimination. You take things one step at a time. I'm going to do a quick view of the chat. Oh, question, what kind of car we have here? This is a Mazda RX-7. This is an FB, so it's kind of weird looking because that's a rotary engine in there.
Okay.
And it's all stripped down because it's a race car. So this car doesn't even drive around on the street or anything. So a lot of the emission stuff has been pulled off of there. And great little race car engine, man. Rotary engines are just so neat.
It's a street car, just not a legal street car.
Yeah, well, so they're rotary engines are really, they have a hard time getting through emissions. So, you know, the beauty of this one is I don't have to worry about emissions. They make great race motors. Like one thing that happens that actually happened to one of my students in driving school this year, he had rented a spec Mustang, which is like a late model, 2007 to maybe 2015 Ford Mustang. So it's got the 4.6 liter V8 or the 5 liter or whatever, really fast race car. He missed a shift. He was going down to turn one and he wanted to go, he was going down the straightaway. He wanted to go into fourth gear and he went back into second gear and floated those valves and basically damaged that motor. And it still ran and he was able to finish driver's school, but now he owes the car owner like $5,000 for a new motor on that thing. The nice thing about these is there's no pistons and valves. And so if you missed a shift, it's likely not going to hurt that motor because these things can rev to the moon. So anyways, great little race car motors. Not the best motors for your typical street car that has to meet smog and that you're worried about getting good fuel economy on. So that's what this video clip was made off of. But the type of engine really doesn't matter. It has a starter motor that's just the same as we've gone over. It's got a battery that's just the same as what we've gone over. And an alternator, all that for the most part is normal car stuff. So,
Hey,
all right.
Mr. French,
Yeah.
do you race out Roseville?
No, I race at Thunder Hill, Sonoma, Laguna Seca. I do road racing. So
That is you.
Yeah.
That's
So
you.
we do
That's
road.
cool. I've seen you race. That's really cool.
Yeah. So right on. Anyways, okay, you guys, you have a great week. Be safe out there. Learn lots of stuff. If you have questions, blow up my email. I'll get with you guys. I look forward to seeing your results. I look forward to reading some more of your comments on the discussions. And again, I like to say, keep learning, keep having fun, guys. And that's all I have for tonight. So good night, everybody.